Welcome to IstioCon. I am so excited you are watching us today. Let me quickly introduce myself. I'm the director of open source with Solo.io. I've been contributing to the Istio project since the beginning for the past 5 years. And a little bit fun side about me is I actually drew the painting behind me myself a couple of weeks ago because I couldn't find a painting to match the boat. So I hope you like it.
And hi, my name is Mitch Connors, and I'm a software engineer at Google, joining this morning from sunny Seattle, Washington. I joined the Istio project in 2018, and I currently co-lead the User Experience Working Group. Quirky fact about me, I have the dubious distinction of the largest handcrafted commit to the Istio repository, weighing in at 16,500 lines of code. Wouldn't recommend it. Don't try that at home. I'm also fortunate enough to be this week's Kubernetes podcast guest. So if you're interested in hearing about behind the scenes from conference planning or more about the User Experience Working Group, check us out on your favorite podcast app.
That's awesome. I hope you also comment in the chat and let us know where you are joining us from your office. I'm from North Carolina and Cary. I'd like to take a minute to thank our sponsors. Without them, we wouldn't be able to have the conference. Also, our program committees, and I want to especially shout out in the program committee to Jason, who is joining us from the end user companies to be able to make sure we have a balanced talks. So in case you're wondering what program committee folks does, is we review your talks, we rate them, we make sure the talks we put together for the conference are interesting, challenging, and the speakers are well represented. I also want to take a minute to thank our organizer committees and a lot of people working through the conferences behind the scene for us. I want to shout out to Maria, who is supervised the IstioCon, putting out the sponsor program out for us, and also Petro, who sits on every single call with us, regardless how boring it might be, listen to us and put out the schedule for us for the conference. Logistically for the conference, the same Istio community code of conduct would also apply to IstioCon. Please join us at the IstioCon Slack, in our Istio Slack. Check out the website of IstioCon for swags, and also if you are looking for other job opportunities, there are actually a lot of opportunities, jobs out there. As far as networking event, we got a very exciting event planned for you this Tuesday on the escape room. So please register today because there are limited spots for that. We also got a couple of listening sessions to make sure we hear the voice from the community, from every one of you. Make sure, let us know the feedback of the conference by clicking on the survey. There's a chance to win 100 Amazon gift card out of the surveys. The workshops, I believe we still have couple of workshops are open, so make sure register if they are interested. The Istio workshop on 0 to 6 is full, but all the rest of the workshops are still available. As far as recording for the conference, same as last year, all the recordings will be available immediately after each session in Cloudcast. Eventually, after the conference ends, it will also be available in YouTube.
And now I'd like you to join me in welcoming our new maintainers to the Istio project. These individuals have shown sustained investment in authoring design docs, hosting meetings, writing code, fixing bugs, writing documentation, reviewing designs and changes. So let's have a virtual round of applause for our new maintainers. Let's also extend a warm welcome and thank you to our release managers. These individuals are involved from the very beginning of the release planning process through development and testing of the release, but once the release has shipped, their job is not over. For 32 weeks after the release, they manage monthly patch releases to make sure that you have your installations patched against critical vulnerabilities and known bugs. So let's hear it for our release managers. I'd also like to welcome 51 new members to the Istio project this year. Membership indicates that these users intend to be active in the community on a regular basis and have successfully authored at least one merged pull request. Welcome to our new team members. Are you interested in becoming a member, maintainer, release manager, or lead? Regardless of your background or area of expertise, if you are passionate about Istio, we believe our community will be a better place with you in it. Join our community listening session on Thursday at 11 o'clock Pacific to hear more about ways to get involved and to let us know how we can make the Istio community a more accessible, inviting place for contributors like you.
Who likes our new Istio.io website? Please do comment in the chat and let us know. So huge shout out to Craig Box for leading this effort, bring Istio to a modern website. Congratulations to all the new Istio users, some big brand name like SAP to some middle-sized company like Constant Contact, right? It's so exciting to welcome you to the new Istio user family. If you haven't added yourself to the Istio.io website as a user, you can click on the link which we will send to the chat to add yourself to the growing list of Istio users. Also, I want to take a minute to congratulate to all the book authors. These are the authors who enable everybody, every user to running Istio, learning Istio, to debugging Istio in production, and along with our new book, Istio in Action by Christian and Reno.
And now, we'd like to share a message from the Istio Steering Committee in anticipation of the 5th anniversary of the Istio project next month. Take it away, Steering.
Hello, Istio community. Congratulations on the 50th anniversary of the Istio project. I am Srihari Angaluri, product manager with the IBM Cloud Platform. I was introduced to the Istio project in 2017 at the Red Hat Summit conference, and I was quite impressed to see such a project coming along, and IBM being the co-creator of Istio. So Istio has become the #1 service mesh solution today due to the hard work and innovations of this community of developers, users, and partners. So congratulations, and looking forward to more innovations together.
Hey everybody, I'm Louis Ryan. I am one of the tech leads for Istio here at Google. And I've been with the project since the very beginning, and I hope you all realize by now that this is the 5th anniversary of Istio in open source. So, that's a pretty big milestone, and I look forward to celebrating this birthday with you all together at IstioCon. There's a lot of great talks in the schedule, and so I'm looking forward to seeing what everyone's been cooking up. Say hi as we roam the virtual halls of this conference together.
大家好，我是刘启军。从2019年开始，一直在社区参与维护 Istio 项目，主要工作集中在 Docs Networking 和 Environment 等模块。目前在 Doc Cloud 负责服务网格的技术落地和推广等工作。Istio 作为目前最热门的服务网格项目，在各行各业中以基础抽色方式向上层应用提供如服务治理可观测性的能力，受到了广大客户的好评。在 Istio 社区5周年之际，祝社区能够蓬勃发展，也欢迎更多的人加入我们。
As a founding Istio TOC and steering committee member, I had many opportunity to work on some other projects for the past 5 years, but I always said no because I firmly believe Istio will become the Kubernetes for service mesh, enabling operators to connect, secure, and observe microservices for application developers.
大家好，我叫 Iris 丁少军，来自英特尔，目前主要从事 Istio 的技术研发和落地工作。那 Istio 在服务网格领域有非常大的影响力，仅在中国而言，就有多家企业正在基于 Istio 在自己的系统中使用服务网格的能力，或者正在对外提供这种能力。那英特尔也一直在跟社区一道，一起致力于如何使用底层的硬件能力，来使得 Istio 的服务网格更加的安全、高效和更加的简化。在 Istio 社区生日5周年之际，衷心的祝福社区蓬勃发展，天天向上。
Hi, my name's Simon Seagrave and I'm the Product Marketing Manager for Red Hat's OpenShift Service Mesh. Here at Red Hat, we were an early adopter of Istio, as we identified that it had many of the qualities we were looking for in an effective Kubernetes-based service mesh. To us, Istio represents a vibrant, large, multi-vendor community that is constantly innovating around application-aware networking. We look forward to collaborating with the Istio community on even better solutions for enterprise customers, in particular multi-tenancy and multi-cluster. So on behalf of the Red Hat and the OpenShift Service Mesh team, congratulations to Istio on its 5th birthday and a massive thanks to this great community.
Well, a big thank you to our steering committee for their kind wishes and for their continued support of the Istio project. And now, as we kick off IstioCon 2022, let's take a moment to look back and see how far we've come together this year. At last year's IstioCon, we shared the Istio 2021 roadmap, which was all about Day 2 operations. We began the Istio project with a focus on Day 0, working to define what a service mesh is and does to make the value clear to our users. After the 1.0 milestone, we focused heavily on Day 1 activities, installation, setup, and onboarding in Istio. By directing our focus to Day 2, we aim to reduce the toil of keeping Istio running, especially the cost of upgrades. So let's take a look at how we've done. In Istio 1.10, we added stable revision tags to support upgrading without relabeling your workloads. In Istio 1.11, we improved revisions to allow for migration from non-revisioned installs. In 1.12, we added gateway injection, which aligned the gateway lifecycle with the data plane, as well as reworking the Helm data charts and publishing them to their own repo for usability. In 1.13, we've added support for default injection, meaning you can now onboard to Istio without adding any labels to your workloads. Our upgrades surveys show that this is working. Each release is rated easier to upgrade than the last, and a big thank you to our survey participants. We've also worked to make mandatory upgrades less frequent. We've added support and testing for direct upgrades across 2 minor versions, for example, from 1.11 directly to 1.13. We've also extended the support window by 6 weeks to allow support to overlap across 2 minor versions. As a result, users can now upgrade twice a year rather than 4 times, with 6-week windows for each upgrade. In the last 6 months, 20% of our Istio upgrades have used this biannual cadence, cutting their Day 2 toil in half. We know that we still have a long way to go. Come and tell us how we're doing on upgrades and how we can improve at our upgrades listening session this Tuesday at 11 o'clock Pacific. 2021 was also a headline year for Istio security. We contracted NCC Group to conduct an independent third-party assessment of the project, to identify security issues related to Istio's codebase, highlight high-risk configurations commonly used by administrators, and to provide perspective on whether the security features sufficiently address the concerns they're designed to provide. You can read the results at the link on your screen, but the TLDR is that no critical issues were identified in the project. They did recommend a best practices guide, which you can find on that same blog post, and we'll hear more about tomorrow at 10:20 Pacific.
How many of you are Kubernetes users today? When you deploy pods and services, you expect it to work, right? When it doesn't work, you don't think it's a problem of Kubernetes itself, unless you are maybe working on some of the experimental feature of Kubernetes, right? So you check your application log, you check resources for Kubernetes, making sure your pods have sufficient CPU memory and disk. The last thing you would think it's you heard about a Kubernetes issue unless really you are using advanced or experimental feature and not basic Kubernetes, right? With Istio, we have the same exact goal. We know we are not as boring as Kubernetes, but it's our intention to keep Istio as boring as Kubernetes. So when you run your services in Istio, the last thing you can think of is, hey, did the pilot push this thing down? Hey, did I mess up anything with my sidecar? We want you to have the same experience. So it's a problem with your resources, or it's a problem maybe with your application. So let's take a look at what the community has done to make Istio boring so that Istio could be as boring as Kubernetes, hopefully soon. The biggest change is the pods networking changes. Many applications are listening on both pod IP and also the loopback interface, which is 127.0.0.1. However, some of the application may choose to bind only to pod IP, or maybe only to the loopback interface 127.0.0.1, especially around stateful set application in Kubernetes. So prior to Istio 110, application that listen on the pod IP, which is ISO 0 instead of 0000, often have issues to work with Istio. Mostly are related to stateful set, but it's not all of just the stateful set. I actually remember 3 years ago at a Thanksgiving holiday, I was debugging a problem with Zookeeper with one of our users working on Istio. It was super hard. The moment we added mutual TLS to the Zookeeper pods, everything starts to falling apart. The pods didn't even reach running. So with Istio 110, the pods networking changes is making sure the moment you inject the sidecar proxy with Envoy to your pod, the pods network stays the same as exactly what they were before the Envoy sidecar is injected. So we are providing a transparent pods networking experience to you as you inject the sidecar to your services running in the service mesh. So a big change in Istio 110, I believe it's being perceived very favorably to many of our users, especially users running with stateful sets. We also did a lot of feature promotions. A lot of features were promoted to alpha, a lot of features were promoted to beta, along with many of features remain as stable. So many of the core features you need from Istio, such as mutual TLS, traffic management, gateway, and different protocols, right? The service credential distribution, all that remains as stable for our user. The beta graduation, we realized after listening to many of the users, Istio CNI has been very popular. So we graduated Istio CNI to beta so that you can feel more comfortable about running Istio CNI in your production environment. External control plane has been used by some of our largest cloud provider. So that's also beta now. Gateway injection provides an innovative way to deploy the gateway so that the gateway can be managed as similarly as your regular workloads. So you can just restart the gateway to pick up the upgrades of the gateway. And also DNS proxy, extremely useful feature for folks running multi-cluster service mesh with Istio. So DNS proxy provide a fundamental method to enable that. I'm so excited to see this feature being promoted to beta for you. In addition to make Istio boring, another key theme of the project is the continuous innovation to innovate based on the features our customer needs. WasmPlugin is a new resource introduced in Istio. The way WasmPlugin resource works is, as a user, you tell us what is your WasmPlugin resource, what images you are using, and which workload the WasmPlugin resource is going to apply to. You deploy that resources to your Kubernetes cluster, and then IstioD is going to push the configurations through the ECDS config to the Istio agent, and then Istio agent is going to check if the WASM binary is already available for the pod locally. If not, it's going to reach out to the OCI image registry. I think it also works with a remote HTTP server to download the image, and then eventually it's going to push that binary and make it available to Envoy proxy. What's most important about this WASM plugin resources, there's no need for you to redeploy any of your workloads. So if you're running Booking.for or any of the services, it would pick up the automatically extension from the WASM plugin resource.
Another innovation in the Istio project this year has been the Telemetry v2 API. With this change, you can have workload level control over metrics, tracing, and access logging without having to reinstall Istio, allowing application owners to integrate with their telemetry backend of choice. If you'd like to learn more, be sure to catch Understanding Telemetry v2 on Wednesday at 9 o'clock Pacific. This API is currently in alpha, so if you've kicked the tires, we'd love to hear what you think. Join us at our Telemetry v2 listening session on Wednesday at 11 o'clock Pacific.
So why proxy configuration, right? What's the purpose? Maybe you need to customize your proxy image. Maybe you need to specify Istio-specific environment variable. Maybe you need to configure concurrency for your proxy, or maybe you need to configure hold the application until your proxy is ready, right? So that's what proxy configuration is for. So the Istio project introduced proxy config inside of mesh config initially, but that has an issue. The moment you need to customize your proxy, you need to talk to your mesh admin to make a change. Then Istio project introduced the proxy config annotation, which is pretty nice, but you have to change your application deployment YAML to add that annotation. And sometimes user add the annotation in the wrong spot. So the latest innovation from upstream community is the proxy config resource, where you can specify whether the proxy config resource is mesh-wide or per namespace or particular workload. So very easy to use, and they currently support a couple of configuration options.
Istio has also continued to drive the state-of-the-art in gateway management. The new gateway injection feature allows you to define your gateway with a simple template. Istio will add all the necessary config and will upgrade your gateway just like it does the proxy today. With the Kubernetes Gateway API for Istio, users now have a single interface to provision and configure Istio gateways. The interface is shared with dozens of other cloud-native gateways, making it easier than ever to migrate to Istio. Together, these innovations provide a single interface for complete lifecycle management of your gateway. If you'd like to hear more, tune in Thursday at 9:40 Pacific for our State of Gateway update.
By default, Istio watches all namespaces, services, endpoints, and pods in a cluster. This actually is a surprise to many of our customers that we work with, regardless whether they are running a large cluster or even a middle-sized cluster. Not every single services are in the mesh, so they were very surprised with this behavior. So Discovery Selector was introduced in Istio to allow mesh admin to be able to configure what are the namespaces the Istio D should be listen and watch out for, so that it could be working more efficient and only care about the resource the user really care about, and don't confuse that with the sidecar resource, which is filtering on the Istio configuration, such as virtual services, destination rules, service entry, not on the Kubernetes resources as a discovery selector.
Well, as you can see, there is a lot going on in the Istio project today. And while we want to keep Istio boring, the work that we do together along the way is anything but. Now, it's my pleasure to welcome to the virtual stage Eric Brewer, the area tech lead over Istio, Spanner, and other teams at Google. Eric's resume is longer than my arm, which means he needs no introduction, but I was amazed to learn that he is the inventor of the CAP theorem. As a matter of fact, it's also known as Brewer's theorem. This means if it weren't for Eric, we would be able to have distributed data stores which are consistent, available, and partition tolerant. That's right, everyone. It's all his fault. Welcome to IstioCon, Eric.
Hi, I'm Eric Brewer from Google. I'm here to talk about Zero Trust in Istio today. Now, I was involved in Istio from the beginning, and it was actually quite a bit of fun, and it's been quite a journey. I just want to point out that Istio started actually with many ideas of Zero Trust built in, and we'll see why that is later in the talk. But the strategy that matters here is a few things. It's first that at the core, Istio is about kind of decoupling policies from your actual source code and applications. Historically, if you have an application with the source code containing the policy, then it's hard to change the policy, right? You have to redeploy the application. But kind of worse than that, it's actually hard to be consistent across all your applications, or in this case, all your microservices, and make sure they all have the same policies, and that when someone does a launch, that the new thing also has the same policies. And so when I say decouple, what I mean is that the platform team can set the policies and update them as they like, and application developers can build services and applications without breaking the policies, and without really even worrying about how do you get the policies right, given the changing nature of these things. Zero trust is one particular kind of policy decoupling, meaning how do we get a zero trust architecture, which I'll define in the rest of this talk. That's an important policy that we get out of having this decoupling. And then kind of the third part of the strategy is, well, once you have a proxy implementing policies, it turns out it's useful for a bunch of other things like traffic management and telemetry. And so you use it as a framework in general for adding value to microservices. So what is zero trust and how did we get here? And it comes back to classic firewalls, what we call the castle approach. So in the castle approach, you have a firewall around what you value, and you believe incorrectly that that firewall will protect you from all of the bad things. And in fact, it doesn't. And for example, you now have mobile workers, people working from home. They're actually outside your physical firewall, but inside your network, right? They must be to get their work done. You, of course, have insider threats. You have vendors and extra groups that work with you that you may not trust as much as some other groups that you work with. And you have, of course, tons of different devices, some of which expect to have internet access. So in general, all these things kind of, once you're inside the castle, there's no protection. So when we talk about zero trust, what we really mean is even inside the castle, we're not actually trusting that everything is working perfectly, right? So we're not depending just on the walls of the castle. And this was brought home to Google in 2009 in an attack called Aurora, in which many companies were attacked. Google was one of them, and the attacker, which was a nation state, was able to kind of get inside the castle and wreak great havoc. Because again, the model is we'll keep you out of the castle, but if that fails, then everything is exposed, right? And that's really what we're trying to get away from. So to get beyond firewalls, there's a few things we have to do. The first thing is what we call Beyond Corp, and this is written about 10 years ago initially, which is when we give you access to something, it's not just because you're in the network, it's because we understand who you are and what your device you're using. So things like two-factor authentications are part of that more fine-grained authentication. And in particular, when you're inside the network or connecting from a particular network, that doesn't mean per se that you have any access rights, right? Because we don't trust the network. We're having zero trust in the network itself as being a meaningful security barrier. And finally, that all of your access is authenticated. We know who you are. is authorized. You have the right to do what you're trying to do. And of course, it's encrypted in case someone is spying on the traffic. Even on the inside of the network, we generally want to keep things encrypted. Another kind of zero trust that's less talked about, but actually more important and more relevant to Istio is called Beyond Prod. This is a second paper produced by Google less than 10 years ago, newer paper. And it basically talks about not so much end users to your network, but actually the services themselves. And when you get to lots and lots of services, at the time this work was done, Google had ordered 100,000 microservices, which sounds like a crazy number, but it grows every year, and it's much higher than that now. So there's no inherent mutual trust among these services. When I say that, things like service A calling service B, well, how does service B really know it's the real service A, right? If you're trusting the network, then you say, oh, the packets came in from my network, they must therefore be trustworthy. In zero trust, we're not making that assumption. We really want to prove that the service that's calling me is really who it says it is, right? Not only that, that it's actually running approved binaries that were built the right way, so those weren't tampered with, and that's running on an approved machine, that we can trust the machine and the OS, right? And that finally we have automated ways to do updates to software, because if you can't do security updates quickly, none of the rest of the stuff is going to work. So those are kind of the two vehicles of zero trust, these kind of end user focus for Beyond Corp and kind of service and infrastructure focus for Beyond Prod. Now, to do Beyond Prod, you have to actually think about it in kind of two pieces, one of which is related to Istio and one of which is not. The first part is, how do I build and deploy my microservices such that I'm actually able to enforce that it's a trustworthy service running on a trustworthy machine, right? How is it built? This directly relates to a lot of other work I've been doing around supply chain security. Things like Log4j, is the right version of Log4j in your image, and do you trust that image? And if it's not, how do you get it rebuilt and redeployed? That's the kind of build and deploy side. The other side is the runtime side. This is where Istio comes in. I have workloads running, and now I know that service A or workload 1 is actually workload 1. It has the right binary image, it has the right credentials, and we know it's running on a trustworthy machine, but it still has to prove itself to other services like workload 2. And that is where we use the Istio service mesh to do the mutual TLS authentication among those services using the right credentials. So in this model, I have my two workloads. One of them's a client of the other. How do I trust my production client? And the way to think about this is, what are the risks and what are the controls we put in for those risks? And in general, the part on the right summarizes that quite well. We're trying to get the right peer, right service you're talking to with the right credentials on behalf of the right user, particularly for end users being represented by actions. And so when you look at the list of risks, it's all kinds of things. But for example, we want to make sure that you can't listen in on the payload. So if we are assuming that network is not necessarily safe, that's what zero trust means. So there may be lurkers in the network spying on the traffic. Even though it's inside our quote unquote firewall, we still want this traffic encrypted. So the MTLS and Istio takes care of that. And in general, that encryption is the right approach for that risk. I'd like to make sure that clients can't pretend to be other clients, right? Just because you have a job running on a machine, it doesn't mean that job should be able to act as other entities and use their credentials. So we really need to prove, what entity is this service supposed to be and what credentials does it have? And so all clients, in this case, these are client services, are explicitly authorized and have an explicit ID. We'd like to avoid replay attacks. That means basically if I send you a token, I should have to send you a different token for the next time I use an action, so that I can't just steal a token and then replay that action. I want to make sure that if I have a client, it can't actually access all the data in our systems, just the data it was narrowly granted. So that means you have to have some way to say, this client is entitled to just this small part of the data, and how to narrow the scope. We'll give an example of that coming up. And finally, the hardest case of all, what about insider risk? So insider has access to the network, they're running jobs inside our castle, so to speak, and what can their job do and how do we limit them? Even though in general we view them as a trusted user, we'd still like to limit what they can do. And by the way, also, which we don't talk about today, but equally important, audit what they do. A lot of times you can't catch the insider and prevent their access, but you can audit it, and that is enough of a deterrent because it really helps you catch them. And also, if you have good audit logs, if you find an insider attack, you can then figure out all the other things they might have touched, right? So that's very important kind of control. Using Istio to do this, there's a few different aspects to how this works. First, there's how do we actually secure the workload itself. So in this case, I have a front-end service and a back-end service, and we're doing really the simple case of we're just trying to say, is caller A calling caller B, and is it really the right front end calling the right back end? And so each of these services has an identity, which you can think of as a signed certificate. These are automatically managed. And then we use those certificates to do the MTLS connection to get the traffic automatically encrypted, right? So what's nice about this is when you write a service or an application, you don't worry about any of this. That's really the beauty of the decoupling of Istio, is it's in the framework that we're doing the automatic certificate generation and key management for all the services at the same time. We have a policy that says what should be encrypted, and then we can encrypt it. And you get a bunch of these other things, risk mitigations, built into the system directly. Right, and that's really what you want. You really want encryption built in, identity built in, authenticity checks built in, and then what you're left with is application developers can work on what's the application supposed to do. And they, in fact, can't get these things wrong because they're, again, not in the source code, it's in the infrastructure. So that's the easiest example. A harder example is now we want to have a front end, back end, but we would like to do it on behalf of an end user. And so the goal here is get the right peer with the right credential on behalf of the right user. Right? In particular, I don't want a client to be able to emulate all possible users, because then they could exfiltrate all of our user data. Right? So in theory, they're doing a task on behalf of one customer for a credit card transaction. In this case, how do we make sure that they can only access that customer's data and no other? And the way this works, again, because we wanted to narrow the trust as much as possible, is using a Java Web Token, or a JOT. That's a token. That means it's a cryptographically signed thing that says this is this user's token for accessing their records. That's actually passed in from the browser. So we get the token from the end user, right? That's passed into the service. And then when the service does the access, it says, oh, I'm accessing the back end on behalf of this user, and I can prove it because I have the user's token, which, by the way, is temporary, so it doesn't last forever. And then I can have policies that say, yes, you can deliver this data as long as it's from the right authenticated service with a properly provisioned Java Web Token that says this end user authorized this transaction. And then you, by the way, you put that in the audit log so that we know that's actually what happened. Well, that's quite a bit more complicated case, but again, this is how all the Google services work. They don't all use Istio, but the way they work in general is this kind of thing where we have tokens that represent users, and we check both the accessing peer client, but also the JOT, or the token that's coming with it, to make sure that it really is for the end user that they say. And in fact, unless you present a token for user's data, you can't get to user data. So really, it's a very strong kind of guard. It narrows access quite a bit. Go to the next case, which is even harder, where now we're worried about an insider and what they can do. And like I said, this is the hardest kind of prevent, but we have some mitigations already enabled by Istio. And again, combined with audit logging goes a long way. So here we want to make sure we have the right front end talking to the right back end, but also that the access is made on behalf of a strongly authentic insider, meaning that we know it's really someone who's supposed to have this kind of access. You can think of it as someone like is doing customer support, and they need access to private data for their job as customer support. And so they have some legitimate need to do the action they're trying to do. And so the way this works, and this is showed with the identity-aware proxy, but you can do this with an OAuth 2 proxy as well. You have the insider authenticate to the external proxy. That actually says, yes, this is really the insider that we believe it is, and we can prove that, again, where you would use something like two-factor authentication. That enables the credit card front end to say, oh, yes, this user using the case tool, for example, can actually access the back-end data because they're doing a customer support case. But the same user running their personal script, represented on the bottom right, actually cannot get access to the data because the access is tied both to their identity, but also to the tool they're using, right? And so the path they come in on matters, and we can enforce path-based access using Istio and the policies we have. So basically, if you go on the right path, it's through the approved tool, you can access the data. If you go through your own, say, bash script running still inside the network, it's in the castle, but it's not the approved tool, it will not have access. So you can't just write a script to get data, even though you temporarily have access to that data in your proper job role. That's the kind of, again, narrowing of scope that we're trying to get for the maximum security. So this is a harder case, and frankly, not as many groups do this, but the point is, this is possible with Istio, and it really is a very effective long-term thing to bet on. So what's next for Istio? And that's super exciting, and I want to kind of go back to the history a little bit and talk about the next step. So Istio came out, it started as a joint project with Google and IBM and Lyft. We all had somewhat similar visions of parts of the things we wanted to do. And that was in 2017, having already done Kubernetes in 2014, it was kind of a follow-on. One way to think about this is you don't need Istio, frankly, unless you have a lot of microservices. But Kubernetes made it easy to have a lot of microservices. That's kind of the purpose of Kubernetes, and even the things like Borg internally at Google that predated it. I said we had 100,000 microservices back then, and it's larger now. When you have lots of microservices, that's when you really need some framework support for things like automatic encryption, automatic authentication, key rotation, those kinds of things. So Istio was released to bring that capability to the cloud native approach. And finally, 1.0 came out in 2018 with early users like eBay and Weather Channel. And although Google's been the largest contributor on Istio, it's absolutely been a community-driven effort, and many players making great contributions for quite a long time. What I want to talk about today, though, is our announcement that we are intending to donate Istio to the CNCF. Istio has been an open source project for a long time, but with this change, it will be part of CNCF, the Cloud Native Computing Foundation, and it will have a good long-term home there. And that'll include actually the Istio trademark being transferred from its current place under relative control of Google to the CNCF, where it'll be managed like the Kubernetes trademark is managed. It allows a less risk for the broad community and a more truly open ecosystem. And this is the right time in some sense, because there's been a lot of changes in Istio over the last several years. Version 1.5, for example, made some tremendous changes in re-architecture, and it feels like it's in a great spot and works well with Kubernetes, and we are happy to make this donation to the CNCF. CNCF has to formally accept it, which we hope they will do, and then it'll be part of the kind of collection of things that make this more complete Kubernetes stack. The Kubernetes and its container stack, which has been in CNCF since day one and started it. The service mesh, which will hopefully join as a formally graduated project in the future. It enters in incubation mode. And then Knative, which is the serverless platform that was previously donated to CNCF. And with that, I'll close and thank you for your time. And I'm grateful for the Istio community for all the great work we've done. I look forward to another decade of cloud native coming forward.
Thank you, Eric. Great speech as always. Let's give Eric a virtual round of applause. I am so excited about what Eric just announced. Istio is going to CNCF. This is a great step to make service mesh industry boring and really help our users. Imagine no need to shop around for different service mesh projects. You just pick what's most stable, most deployed in production environment, which also have a great home at CNCF. Now, I want you to turn your attention to these folks. If we can bring up the slides. Yes, in case you're wondering, who are these folks, right? These are the active maintainers of the Istio projects who keep the lights on for the project. Please give them a huge shout out in the chat, how much you appreciate them to make Istio available for you. On behalf of all the active maintainers, we thank you for your interest in the Istio project. And we look forward to interact and learning from each of you at the conference. Enjoy IstioCon, and we hope to see you in person soon.
Thanks, everybody. See you in the Slack.